In this section, I will look at configuring remote access. Nowadays, with most people working away from the office and even more at home, remote access is an important topic to understand. In this video, I will first look at the 3 stages that make up a remote connection. It is important to understand these steps to help you understand networking problems. Next, I will look at NAT. NAT is a technology that allows one public IP address to be used by many computers. On smaller networks and at home, you may, however, want to consider using Internet connection sharing. This is similar to NAT, but requires a dedicated computer to access the Internet. If you want to allow VPN access into your company, Microsoft offers Remote Access Service. Once I look at how Remote Access Service works and how to install it, I will have a closer look at the VPN protocols that make it work. The operating system you are using with Remote Access Server will determine which protocols you make available on it. Next, I will look at Network Policy Server. With remote access, there are a lot of settings to configure. Network Policy Server helps you to configure these settings throughout your environment. Lastly, I will look at Radius. Radius is a system that provides you with centralized control of remote access. In other words, who has access and keeping records of who accesses what. When looking at remote access, it is easiest to look at it in 3 stages. The first is connection. The connection stage makes the physical connection between the 2 parties. At this stage, encryption and protocols are decided. When troubleshooting connection problems, make sure that both sides of the connection support the same protocols and encryption. If they don't, a connection will not be made. If a connection cannot be made, the next step, authentication, cannot occur. The authentication stage identifies whom the connection is being made by. Typically, the connection is identified by username and password or certificates. You could, however, use IP addresses as well, but this is seen as not being very secure. The last stage of remote access is authorization. Authorization determines what can be accessed. This is done through IP filters, which either allow or block connections to certain IP addresses, and NTFS permissions, which block or allow access to files. When troubleshooting remote access problems, try to keep these stages in mind. If you are not being prompted for a username and password, the problem is probably a connection problem. If you keep getting denied access, the problem may be with your certificate or username and password. If everything seems to be working and your connection is up and running, but you can't see or access anything, the problem is probably with authorization. Remember to keep these 3 stages in mind when troubleshooting network problems. With IP version 4 addresses starting to run out, systems had to be devised to help use the available IP addresses a lot better. One of these systems is NAT. NAT stands for Network Address Translation. The concept behind NAT is that many computers communicate with a NAT device. The NAT device communicates with the Internet. As shown here, 4 computers are connected to the same NAT device and share the one public IP address. NAT is very scalable and could be used for hundreds or even thousands of computers. As you can see on the left-hand side, each client computer has its own IP address, but the IP address is a private IP address. NAT is usually found in most DSL modems and is the reason why you can connect multiple computers to the same DSL modem. NAT was designed to better utilize the remaining IP version 4 addresses. With the larger address space in IP version 6, NAT is not required since IP addresses in IP version 6 are far from being scarce. If you want to use NAT with Windows, you will need Windows Server. Client operating systems, such as Windows Vista and Windows 7, do not support NAT. In the real world, you probably won't see Windows used for NAT, as NAT is usually done with hardware devices. NAT is primarily aimed at large businesses. If you have a small business or are a home user, you may want to look at something like ICS. ICS, or Internet Connection Sharing, is used when one computer shares its connection with other computers. For example, imagine this computer was connected to the Internet, but the DSL modem used is a USB modem, and thus can only be connected to one computer at a time. Later on, you wanted to connect some other computers up to the Internet. Since the DSL modem only has one USB connection, you can't connect up any more computers to the connection. With Internet connection sharing, you could connect the other computers up via the main computer. The downside with Internet connection sharing is that the computer that is directly accessing the Internet must always be on for the other computers to access the Internet. One common use for Internet connection sharing is when you place a wireless device on your network, for example, a laptop. You can, of course, upgrade your DSL modem to one that supports wireless, but another solution is to install a network card in the computer running ICS. This will allow your laptop to connect to the Internet using a wireless adapter without having to upgrade any of your existing networking gear. Let's have a look at how to configure ICS. ICS works off an existing network connection. To access an existing network connection, open the control panel and select the option View Network Status and Tasks. From here, you need to select Change Adapter Settings from the right-hand side. This will show you all the currently installed network connections. The one that I am interested in is my SP connection, which is a dial-up connection. ICS works on almost any type of connection. To configure it, select the properties of the connection and then select the tab Sharing. On the Sharing tab, select the option Allow other network users to connect through this computer's Internet connection. Next, I need to select which adapter the other computers are connected to. In this case, it will be a local area connection. You will also notice the option Establish a dial-up connection whenever a computer on my network attempts to access the Internet. This will essentially bring up the connection automatically when one of the computers on your network requests it. ICS is now set up and will allow computers connected to the local area connection to access the Internet. If I select the button Settings, this allows me to set up port forwarding. Port forwarding will forward a request for a particular service to a particular computer. If I were to select Remote Desktop and enter in Workstation 10, all remote desktop connections that come through this Internet connection will be directed to Workstation 10. If you do not set up any port forwarding, then all incoming services will remain on the computer with ICS enabled. Now that you have an understanding of ICS, let's take a look at its bigger brother, Remote Access Service. The Microsoft Remote Access Service provides two basic services for clients. The first is dial-up services. The client will access the RAS server through a modem. Generally, the modem will be in a bank of modems rather than a standalone modem. The RAS server will provide access to the production network for the client connected to that modem. RAS also provides VPN access. Over the years, VPN access has become more common, and nowadays it is rare for anyone to use modem access. When VPN is used, the client creates a tunnel through the public Internet to access the RAS server. This means the RAS server needs to have access to the Internet. For this reason, the RAS server is normally a member server and placed on the DMZ or perimeter network. Doing this helps prevent the RAS server being compromised, and if it is, helps prevent the rest of the network from being compromised as well. To install the Remote Access Server, launch Server Manager from the Start menu under Administrative Tools. From the left-hand side, select the option Roles, and then select Add Roles from the right-hand side. If you have watched the previous video on routing, you will remember me doing the same thing as I am going to do now, and that is select Network Policy and Access Services. If I now move on to the Components screen, I need to select Routing and Remote Access Component. You will notice that the Routing component is also selected. This is not required for remote access, so I will deselect it. I can now move on and start installing the role. Depending on the speed of your server, this role will generally take a few minutes to install. Once completed, I can close Server Manager and then launch the Routing and Remote Access Server tool from Administrative Tools under the Start menu. Routing and remote access in Windows Server 2008 has not changed that much from Windows Server 2003 and Windows Server 2000. So if you have some previous experience in remote access, you should not have many problems configuring it on Windows Server 2008. In order to start using remote access, you need to configure it. To do this, right-click on the remote access server, in this case RAS1, and select the option Configure Routing and Remote Access. This will launch the Routing and Remote Access Server wizard. In this particular case, I want to set up this server to allow remote access, so I will leave it on the default option at the top, Remote Access Dial-Up and VPN. On the next screen, you get to decide if you want this server to support connections via VPN or via dial-up. In this case, I will select both. On most servers providing remote access, they will have more than one network card. One network card will generally be connected to the internet, and the other will be connected to the production network. I will, in this case, select the second network card, as it is the network card to which my clients are connected. Notice also the option Enable Security on the selected interface by setting up static packet filters. This means the local firewall will be configured to deny anything other than VPN traffic. This is one good reason to use the wizard to ensure that these rules are created. Be warned, however, ticking this tick box will deny all traffic through that network card that is not a remote connection. You will no longer be able to receive pings, contact domain controllers, or retrieve web pages. If you have a second network card that will perform these duties, tick this tick box. If not, it is probably best not to tick this box. On the next screen, you can decide from where the clients will get their IP addresses. This can either be from a pool you enter in or from the DHCP server. I have a DHCP server on the network, however for this example I will enter in a manual range. For a client to operate on the network, it needs to be allocated an IP address from the production network. The RAS server makes the client think that it is directly connected to that network, and other devices on the network will also think that it is directly connected. When I set up a RAS server on a network, I like to manually enter in a range of IP addresses, as this helps with troubleshooting. If you have a range of IP addresses that you know is just being used for VPN, then when you see one of those IP addresses in a log file, you know that it came from a remote connection. When you enter in the range of IP addresses, you will only need to enter in the starting IP address and the amount of IP addresses that you want to use. Windows will automatically work out the end IP address for you. Once you have configured how you want your clients to obtain their IP addresses, you will need to decide if you want to use Radius or not. Radius is an authentication system. I will cover Radius in more detail later in this video. For the present, just think of Radius as a system that authenticates users on the network. Radius is often used when you have multiple remote access servers and you want to authenticate them all using one system. Once I press Finish, routing and remote access will be installed. Remote access service does not take long to install. Once done, your RAS server is ready to go. You may, however, want to do some more configuration to the server depending on what type of clients will be connecting. Let's have a look at the protocols RAS supports. The first is PPTP. PPTP, or Point-to-Point Tunneling Protocol, was developed by Microsoft and thus is supported by most Microsoft operating systems. If you are using a non-Microsoft operating system, you will need to use another protocol to connect the VPN server. PPTP is becoming obsolete by newer protocols, but may be your only choice if you have some older Windows operating systems that need to connect to your VPN server. The protocol only supports TCP/IP, which, nowadays with the popularity of the protocol, may not present a problem. The protocol requires TCP port 1723 to be open to operate effectively. The next protocol is L2TP, or Layer 2 Tunneling Protocol. This protocol is an open standard, so you can use it to connect your non-Microsoft clients. L2TP also supports multiple protocols, not just TCP/IP. L2TP can use IPsec for encryption, assuming that you are using certificates in your organization. The downside with L2TP is that it is not supported by older operating systems. L2TP uses TCP port 1701 and UDP port 500 for communication and also has IP version 6 support. L2TP is a better protocol in a lot of ways, but because of its lack of backward support, it is not uncommon for VPN servers to have both PPTP and L2TP configured. With both installed, the client can decide which one it wants to use. The disadvantage with both these protocols is that they require ports that may not normally be open on the firewall to be open to operate. Many administrators do not like opening additional ports on their firewalls, which brings us to the last protocol. SSTP, or Secure Socket Tunneling Protocol, addresses some of the problems with firewalls by using SSL for encryption. SSL uses port 443 to transfer traffic. Because of this, SSTP has better firewall support because port 443 may already be open, as it is commonly used by web traffic to encrypt data. The protocol also supports certificates for authentication if your organization has a certificate authority. The protocol is designed for client access and thus can't be used for site-to-site access. The protocol is new to Windows Server 2008 and has limited support for older clients. When SSTP first arrived, you needed to have Windows Vista with Service Pack 1 or above. Since then, Microsoft has added support to Windows XP with the release of Service Pack 3. SSTP is a good protocol to use and gives you a lot of features if your clients support it. Let's have a look at how to configure and connect to RAS server. First of all, I want to see what protocols are enabled on my RAS server. To do this, select Ports. Here you can see all the ports that are currently waiting connections. You can see a port is waiting for an SSTP connection, and further down, a port waiting for a PPTP connection. If a client was connected to this server, the status would change from inactive to connected. If I now right-click on Ports and select Properties, you can see all the protocols I just talked about. If I press Configure for SSTP, you can see here that by default, it is enabled and accepting remote access connections. SSTP can only be used for incoming connections, so you will notice that the options for outgoing are grayed out. You will also notice that the maximum ports is set to 128 by default. This means that this server can accept 128 SSTP connections. Bear in mind that when I set up the IP address pool, I only allocated 50 IP addresses. If you are planning on having a lot of incoming connections, make sure that your maximum ports is set high enough to support them, and also you have a big enough pool of free IP addresses. If I now select PPTP and again press Configure, you will notice that again I have the option to enable or disable incoming connections. I also have the option to enable or disable demand dial connections. Demand dial connections will create a connection as required. For example, if you had 2 branch offices connected by VPN, a demand dial connection will bring up the connection when the client attempts to use it. The next protocol is L2TP. You can see the options are the same as the other protocols. If you want to disable any of these protocols, just clear the relevant checkbox. The last of the RAS protocols is IKE. This is essentially IPsec, meaning if you want to make a native IPsec connection, RAS supports it. This may be a good option for you if you have non-Windows computers that want to connect up to RAS. To start using RAS, you need to make a connection from a client computer. To do this, I will switch to my Windows 7 computer. I will use Windows 7 as a client for this demonstration, as it is more than likely that a non-Windows Server 2008 will be used to connect to RAS. To create the new connection, open the control panel and then select View Network Status and Tasks. This will take you into the Network and Sharing Center. To start the new connection wizard, select the option Set up a new connection or network. Depending on which version of Windows you are running, the wizard may be a little different and may be launched from a different location. In this case, the option I want is Connect to a Workplace. The wizard can also be used to create a dial-up connection. In this case, I want a VPN connection, so I will select Use My Internet Connection. The next screen will ask you if you want to set up an internet connection to connect to the VPN server. You would select this option if you needed to dial in to an ISP using a modem or if you had to connect via a different connection. When configured correctly, whenever this VPN connection is activated, the connection to the internet will first be opened before trying to connect to the RAS server. On this screen, I need to enter in the IP address or server name of the RAS server. I can also give the connection a suitable name. At the bottom of the screen, you will notice the option Allow other people to use this connection. Ticking this connection will allow other users on the computer to connect using this connection. If this connection connects back to your head office, for example, ticking this option allows you to set up the connection using the administrator, and then any user that logs onto the computer will be able to use the connection. On this screen, you can enter in the username and password for this connection. Just to prove a point, I'm going to use the domain administrator's username and password, which has access to everything on the network. If you are creating a shared connection, it is often a good idea to tick the tick box, Remember this password. If you don't tick this tick box, the user will be prompted for a password each time the connect is run. The connection does not take long to create. Once created, I can select Connect or Disconnect and go down to VPN Work and press Connect to start the connection. You will notice that the connection will fail to connect. Windows will come back saying there was an error verifying the username and password even though I used a domain administrator's account. This is because no user by default has access to the RAS server. To fix this problem, I need to switch to my domain controller. To enable access to the administrator, I need to make a change to the domain administrator's account. To do this, I need to run Active Directory Users and Computers found in Administrative Tools under the Start menu. All I need to do is locate the administrator's account under the user's OU. Select the properties on the administrator account and then go to the Dial-In tab. On this tab, you will see by default, dial-in access is determined by the NPS network policy. I don't have NPS configured on this network as yet. NPS is a system designed to help you control access to your network. Why is it required? Well, if you look at the options above, if I want to enable access to the administrator, I need to select the option Allow Access. If you have a network with thousands of users, you need a system like NPS to simplify administration. In a moment, I will look at how we can use NPS to configure our network. If I now go back to my Windows 7 client and press the Redial button, you will notice that the computer now connects up to the network. You will notice that under Connections, Work VPN has appeared. This computer is now connected to the work network, and to other computers it will appear as if it is on the network even though it is accessing the network through the RAS server. To demonstrate this, if I now open a command prompt from the Start menu and run the command ipconfig, you will notice that the computer now has an IP address of 10.0.0.151. This is one of the IP addresses that I allocated to the RAS server earlier using the configuration wizard. Imagine on a large network with hundreds or even thousands of users having to manually go into Active Directory and configure them to be allowed access to the network via remote access. Back in the Windows NT days, this is what you had to do. Nowadays, we can use NPS to do the hard work for us. NPS, or Network Policy Server, allows you to create rules defining how users can connect to your network. If you have used remote access services before, you may notice NPS is similar to Remote Access Policy. Network Policy Server replaces Remote Access Policy and improves on it. The main role of NPS is to provide authentication and authorization settings. On a large network, it is essential to have something like Network Policy Server to deploy settings. Otherwise, trying to administer dial-in services using Active Directory and manually ticking and unticking boxes for individual users would be a nightmare. Also, as you can see, there are a lot of things you can do with Network Policy Server that you cannot do by modifying the settings in Active Directory or using the Routing and Remote Access tool. Let's have a look at how to use Network Policy Server. I already have the Routing and Remote Access tool open from the previous demonstration. All I need to do is select Remote Access Logging and Policies, right-click it, and select Launch NPS. To see what policies have already been created, select the folder Network Policies. You can see here by default that 2 policies have already been created. They were created during the install, and you can see they both have an access type of deny. The second policy checks the time and checks its rule lists for a match. Its rule list is set for 24/7, so anything that makes it to this policy is going to be denied. This policy acts as a catch-all to ensure any connections that do not match a policy are denied. To create a new policy, right-click Network Policies and select New. For the policy, I will enter in Company VPN, and for the type of policy, I will select Remote Access Server. You will notice that there are a lot of other types of policies available. This is one of the reasons for the name change from Remote Access Policies, because the policies have been expanded to include more than remote access. On the Specify Condition, you need to enter in some conditions this policy will check for. You can enter in more than one set of conditions. For example, you could enter in a user group and a date and time condition. As you can see, there are a lot of different conditions you can set. You can even set conditions based on the protocols being used. In this particular case, I want to create a policy for domain users, so I will select Windows Groups. From here, it is a simple matter of looking up the domain users group in Active Directory and adding it. Once added, any user in the domain users group will be affected by this policy. On this screen, you need to select whether this is an allow or deny policy. In this particular case, I want to allow all domain users to be able to connect to my RAS server. Notice the tick box Access is determined by user dial-in properties. If I tick this tick box, if the conditions of the policy are met, Network Policy Server will then refer to Active Directory and either allow or deny based on the settings in Active Directory. On this screen, you can set the authentication types. At the top, you have EAP types. This basically refers to devices like smart cards. At the bottom of the screen, you have authentication methods. Later in the course, I will go into more details about these authentication methods. On this screen, you can configure some constraints for your connections. First, there is the idle timeout. If you set a value here, for example, 15 minutes, if the user does not perform any activity for 15 minutes, they will be disconnected. The session timeout, when set, will determine how long a session will be allowed to run before it is disconnected. The called station ID can be used to determine from where the connection has been made. If the connection has not been made from an authorized station, it will be disconnected. Day and time restrictions allow the connection only to be made at certain times, and if running outside those times, they will be disconnected. With VPNs and high-speed networks, a lot of these settings are no longer used on most networks. When you had a network with limited modems, settings like these needed to be set up to allow for fair access to these facilities. Without settings like these, modem banks would become jammed and end users would not be able to connect. With VPN, one server can handle a high number of connections, so fair play issues hardly ever come up. The last constraints setting is NAS port types. These settings relate to the type of media the connection comes from. If you want certain settings for wireless and different settings for wired networks, you can set them here. For example, you could require a higher encryption standard for wireless than for VPN traffic. On the next screen, you can configure even more settings. The first two options relate to radius. If your clients are using radius to connect to your server, you can send additional options to the client if you wish. If your vendor has special radius attributes, you can use the next option, Vendor Specific. The multi-link sections refers to using multiple modems together to give you a higher speed. With high-speed internet nowadays, this is hardly worth the effort setting up, but it is on by default if you choose to use it. In the IP filters section, you can set IP filters to block certain traffic. As you can see in the dialog, you can set IP addresses and select different protocols. This allows you to restrict incoming connections from certain addresses and also stop them connecting to certain locations. On the encryption screen, you can set what type of encryption standard will be allowed. It is important to note that no encryption is ticked by default. On your network, you may want to clear this tick box. Depending on the age of the computers that are connecting to your server, you may want to deselect lower encryption options. Remember that high encryption does also put more load on your server. In some cases, you may want to deselect the higher options if you are having performance problems on your server. The last section lets you have more control over how the IP address is allocated to the client. If you want to set static IP addresses or want to let the client choose their own IP address, you will need to set it here. That's it. Press Finish and your new policy has been created. Notice how the policy is the first in the list. This is important. Policies are evaluated in order until a match is made. If, for example, you had the deny policy first, all connections would be denied regardless of what you set in the other policies. When troubleshooting policy problems, make sure to look at any policies that are before the policy in question. If a match is made, Windows will not look at the policy. The last thing that I want to look at is Radius. Radius stands for Remote Authentication Dial-In User Service. Radius allows for the central management of authentication, authorization, and accounting, also known as AAA. If you have a large organization and you want to centralize administration of your remote connections, you should consider installing a Radius server or multiple Radius servers throughout your organization. Radius over the years has expanded from the dial-up service that it was originally aimed at. I have seen Radius set up to use smart cards and secure tokens. When a client connects up to a RAS server, the RAS server will connect to the Radius server and either allow or deny the user. Radius is an open standard, so you will find it is used with other products, not just Microsoft products. If you want to centralize your authentication, authorization, and accounting, consider installing a Radius server. When you start configuring your network for remote access, remember, a lot of protocols and devices are used when a remote connection is made. This means there are a lot of places where problems can occur. When troubleshooting, break the problem down into smaller parts. Can you ping the other side? If so, the connection is fine. The problem may be with authorization. Check the firewall rules the connection is passing through. Certain protocols require some non-standard ports to be open. If these ports are being blocked on the client, server, or a firewall in between the connections, then the connection will fail. Remote access can be a lot of effort to set up, but when it is running, it is worth the effort.